So let's put together a little menu of curve sketching. So, first idea, rewrite it all as one fraction if you can. Find your y-intercept, that's always easy. Substitute in x equals 0, you get your y-intercept. X-intercepts aren't necessarily as easy to find. If it's all one fraction, it's going to be the numerator, because if a fraction equals 0, it has to be the top of the fraction. That's equal to 0. Do a polynomial division, because that will then bring out any asymptotes. So remember this one. So if you've got some polynomial on another polynomial, you can do your polynomial division. You end up with your quotient plus the remainder over the divisor. So the bottom of the fraction, well, we know the bottom of the fraction can't equal 0. So solve that equal to 0. That'll find our vertical asymptotes. The quotient will turn out to be the horizontal or oblique, depending on what sort of function you've got there, asymptote. And then the top of the fraction, that tells you if the curve cuts that horizontal or oblique asymptote. And other things you might take note of, is it an odd function, is it an even function? Because then you know it's got some sort of symmetry happening. And the other one is reflection in y equals x. If you notice, it's its own inverse. So if you swap the y's and the x's around and you get the same equation, then you know it must reflect in y equals x. Right, a little bit about asymptotes themselves. So vertical asymptotes. So they're exclusions in the domain. There's no way the curve will go there. So you cannot touch or cut vertical asymptotes. Your horizontal ones, now that happens when it converges to a single value. So a bit like the limiting sum actually, when it converges to a single value. Now they can cut the horizontal asymptotes. Is possible. 3 limits. Keep in mind these ones. We know bottom of the fraction can't equal 0, but the other thing we know with our hyperbola is that as we approach infinity, because that's what we're interested in with horizontal and oblique asymptotes, what's happening out in infinity? Well, we know the hyperbola is approaching 0. So anytime you've got that sort of function where the pronumeral's on the bottom, then you're going to have that horizontal asymptote. The exponential ones as well, they often come into play. So your e to the minus x, so your exponential that starts out up the top, comes down, gets shallower and shallower, and goes asymptotic to the x-axis. So again, we know out at infinity, that'll be 0. And the other one, the regular exponential, it would be approaching 0 at negative infinity, because it'll be going down the other way. So let's do an example. If I wanted to find the limit as x approaches infinity. Well, the first way we looked at this one was to go, let's divide everything by the highest power. So we'll divide everything by x squared, and so we get 1 over negative 1, which is negative 1. Now, the reality is you don't have to actually divide everything by x squared. All you really need to do is look at the coefficients of the highest power, and that'll tell you. If you got something like this then, e to the power of x plus e to the power of minus x over 2e to the x. What's happening to that out at infinity? I'm going to do a division or a multiplication, depending on how you look at it. So I can get it in terms of either e to the minus something or e to the positive something, because that's the thing I know approaches 0. Now, because it's going to positive infinity, then I want to try to get it as e to the power of minus something. And so I divide everything by the e to the x to get rid of the positive power, and we end up with e to the minus 2x on 1. We know that e to the minus 2x would approach 0, so therefore that limit approaches a half. Now if I had one like this, same fraction, but now what's happening out at negative infinity? Well, negative infinity, the limit I know is when it's e to the power of a positive number. So I want to get rid of those negatives. So this time, if I multiply everything by e to the x, that'll turn the e to the minus x into 1, and the e to the x's become e to the 2x. We know the e to the 2x's are going to approach 0. So what have we got there? We're going to have 1 over 0, which is undefined, but we also think of it as, it's coming from infinity. So this one must be starting over there out at the on the left-hand side. As it approaches negative infinity, the y value is approaching infinity. And of course, you've always got the other way of finding these limits by substituting really big numbers, and if you're still unsure, make them increasingly bigger and bigger and bigger and get a feel for where the curve's heading. All right, let's sketch. Okay, y-intercept, that's always easy to find, I say. X equals 0, x-intercepts, this one can be solved nicely. With the x-intercepts, if the equation's too hard to solve, then sometimes we don't worry about it. You know, we've got an idea roughly where they are. But if it's easy enough to solve, we find them precisely. And in this case, we've got x equals 0 and x equals plus or minus 3. Okay, so we'll plot those in. So there's those 3 points. Now, it's all in one fraction. So we'll do our polynomial division, and we notice now that there's going to be vertical asymptotes at plus or minus 2. So we'll just dot those in. Then there's going to be an oblique asymptote at y equals x. The curve will meet our asymptote though, because you'll notice the top of the fraction can equal 0. So 5x can equal 0. And in fact, we knew that already because we'd already determined that there was an x-intercept here at the origin. And of course, y equals x goes through there. Okay. Now, curves, of course, must bend towards asymptotes. What else do we notice? It's an odd function. So I know it's going to have rotational symmetry. Now, whoop. There's our curve. So I suppose when you look at it, starting from the left, I know I've got to bend towards the asymptotes, but I've got this x-intercept. So therefore, that's the only thing it could do. The other thing that it might do would be trapped in this triangle. But if it was trapped in that triangle, it couldn't go through that x-intercept. So therefore, it must do that part. And by the rotational nature of it, right on the right-hand side, it must do a similar thing. In the middle, I suppose it could have gone the other way, couldn't it? But that's a matter of, I guess, just testing a point to see, well, is it positive, is it negative? So we could pick, say, x equals 1. If you sub x equals 1 in there, we're going to get, there we go, negative 8 on negative 3. So it's going to be a positive number. So we know it's positive. So 3b and 3c on some curve sketching.